section, we're going to be taking a closer look at numbers. Now, these form the foundation of statistics, and so it's important that we make sure that we are clear in certain key points before we move forward. First of all, though it should seem obvious, make sure that when you're working with numbers, you're having very careful precision. For example, when converting a percentage to an actual amount, you need to pay attention to your conversion process along with the actual unit of measurement. In terms of precision, percentages should always sum to a total of 100%. If you're having a sum percentage of 99.5 or 101, that does not make sense. Something must be incorrect. When you're looking at conversions between percentage, fraction, and decimal, your book does an excellent job of covering that on page 11 with good examples. So I suggest if you're not confident with that information, you pause the lecture for a few minutes, go over that, and make sure you've got it in your notes so you can refer back to it later when you have to solve similar questions on the exam. When you finish with that, let's move on to the next slide where we're going to take a look at an example. Okay, here we're going to apply the information covered on page 11 to a problem that is very similar to what you would see on the homework or the exam. Here we're looking at a poll of 2,302 people. And we have 14% that said they have a tattoo. So take a few moments, pause the video, and go through and calculate what is the exact value that is 14% of these 2,302 people. Then go through and look at whether that would be the actual number, and if not, what would be the actual number. When you've completed solving these questions, turn the video back on, advance to the next slide so we can take a look at the answers together, just as we would be doing in class. Okay, here we see the exact value of 14% is 322.28. However, this cannot be the actual number of adults who reported having a tattoo because it does not make sense to have you say you have 322.28 adults. The adults were counted in whole numbers. That means that the actual correct amount must also be reported in whole numbers since that's the unit in which they were measured. This is an issue of paying attention to rounding rules. Many types of statistical analysis have unique rounding rules that must be followed. Here we've used the basic rounding rule of rounding down if you have a value decimal point of 0.49 or less. However, different statistical techniques are going to have their own rounding rules, so make sure you're paying attention to those and adding them into your notes as you go along. Looking at the last part of the question, looking at the respondents, 46 people said they had a face piercing only. So the percentage of that would be 2%. If you're not clear about these answers, go back and take a look at the material on page 11 and make sure you can work through these problems till you have them correct. When you finish that, move on to the next slide. Here we need to take a few moments and make sure we know which type of number we're talking about. So when we're doing measurements, we can have either a parameter or a statistic. Your book does a good job of talking about the differences between the two on page 16. So I suggest you take a moment, turn off this PowerPoint, and go through and look at the definitions and get them into your text along with some specific examples. So again, you have them available to refer to during the homeworks and the exams. Once you've done that, turn the video back on and let's look at the information together. Notice that both the parameter and the statistics are numerical measurements describing some characteristic. The key difference between the two is the word population and sample. A population is all of the individuals of the group that I'm interested in. A sample is a subset of the individuals from the group that I'm interested in. So let's look at how this would apply, for example, looking at your Exam 1 scores. If I was interested in your Exam 1 scores for the students in this course, and I calculated the mean of every student's score, putting them all together, then the resulting mean would be a parameter. However, if I only selected 8 of you and then calculated the mean of those scores, I would be working with a sample of the students in the course, and the resulting mean would be a statistic. Take a moment to look at this symbol table at the front of your text and notice that we have different statistical symbols for a mean calculated from a population and one calculated from a sample. If it's something from a population, it is called a mu, and it's indicated by the symbol on the left. If it is from a sample, we call it the sample mean, or often x bar, and this is indicated by the symbol on the right. Make sure you keep these symbols separated in your notes and clearly labeled so that you do not have later confusions that can lead to incorrect responses. Now, again, let's practice and apply what we've been working with so far. So, pause this video and take a few moments to read through these two problems and determine for each of them whether the value is a statistic or parameter. Once you feel you have the answers for that, turn the video back on and advance to the next slide, just as we would in class, to check the answers together. Number 6 is a parameter. All states are included in this count. Number 9 is a statistic. Here we are using an IQ score from a group of people to make an assessment about an inference about the mean IQ score for all adults. Thus, all adults would be the population, and the individuals, subjects that we use to give them the IQ test, is the sample. That means that any resulting score would be a statistic, not a parameter. The next thing we need to look at is different types of data. Two of the basic breakdowns of data type are categorical and quantitative. Looking at categorical data, read through the definition, make sure you're clear about what that is and what are some good examples of that. Once you have that clearly in your notes, then advance to the next slide. All right, categorical data, it's often called qualitative data, and this data consists of names or labels that are not numbers representing counts or measurements. So, for example, your program of study would be a categorical type of data, or the state you live in. Now let's take a look at quantitative. Answer the same questions for these. Make sure you're looking at how they differ from categorical data, and then move on to the next slide to review the answer together. Quantitative data consists of numbers that represent counts or measurements. In this example, the amount of money that you currently have in your bank account would be quantitative data, or how many miles you drive each day to class. Now, let's do a quick practice here. Below are two sets of data. Take a moment and pause the video and determine the type of data, categorical or quantitative, in each set. Go back through your notes to help you answer this question. When you feel you've got the answer for each of these sets of data, turn the video back on to move on to the next slide, where we'll check the answer together just as we would in class. The one on the right is a quantitative data. The weight is a measurement. Thus, we have measured the individual's weight. The one on the left is qualitative or categorical data. A jersey number is assigned, not counted or measured. This is an example of a number representing something or someone. If we look back at the definition for categorical, we notice that it includes that numbers do not represent counts or measures. It does not necessarily exclude numbers altogether. Let's look at some similar examples of this event. One of them would be your student ID number. Those are numbers, however, they're used to distinguish you as an individual. They're not exactly anything that we would measure or count. That would not be meaningful. Your license plate might be another example, depending upon your particular state and how it's organized, as to where you have numbers as part of something designating a category, not an actual measurement. All right, now we're going to look at different types of quantitative data. So we're breaking it down from categories or qualitative data and quantitative data, and now we're going deeper in quantitative data to look at how this breaks down into two further types of data. So these are discrete data and continuous data. Take a few moments to make sure you get a clear definition of each of them, paying attention once again to what's the distinguishing characteristics between them, and see if you can generate an example of your own for each. When you finish doing that, turn the video back on and advance to the next slide, and we'll review over this together. A discrete data would be a number of values that is finite or countable. For example, the number of students in this course. Continuous data has an infinite possible values which must be measured. An example of that would be the heights of students in this course. Now, if you're feeling a bit confused or frustrated by this and you're not sure you're able to tell the difference between the two, I've got a helpful tip for you. Focus on the words countable and measurable. Notice that in discrete data, we count the data, whereas in continuous, we're going to be measuring it. If it does not make sense to measure the characteristic, then it is discrete. Let's take another look at this again. Look at the two different types of data on the right, which is determine if they are continuous or discrete. Pause the video here, take a few minutes to work through your notes and the examples to get your answer, and then, when you feel you've got the correct answer, turn the video back on to advance to the next slide, where we'll be able to review over it together. The number of cars in the restaurant parking lot is discrete. We would be able to count the number of cars. It would not make sense to say you have 20.3 cars. However, the distance that was driven is continuous, as we would measure the miles driven, and you can have 235.6 miles driven by all the cars in the parking lot. All right, let's try one more practice with this, similar to the types of problems you would have on the homework in the exam. Determine which of the following are discrete or continuous measurements. Again, pause the video here for a moment, work through the problems yourself using your notes, and then turn the video back on to check your answer. Number 14 would be discrete. A Honda Civic having 4 cylinders is something we would count. Remember, it wouldn't make sense to say having 4.2 cylinders. That would be meaningless, as it's not possible. However, number 15 is George Washington's height. That would be continuous. We measure a person's height, and in fact, it would be meaningful to say that his height was 188.23 centimeters. That would make sense. The last thing we're looking at in this particular session is levels of measure. Your book does a very nice job of discussing those again, and also provides a nice summary table over on page 20 at the bottom. We have 4 different levels of measurement, and we're actually going to start at the bottom. We're going to be doing nominal, ordinal, interval, and ratio. Let's take a look at the definitions for each, and then also look at some examples. So, we want to start at the bottom. Nominal data are categories only. This is data that can be arranged in any order. Examples of this include your college major or the color of your car. There's no inherent meaning in putting one color before another when describing car color, or, for example, putting one college major ahead of another. The next is ordinal. Here, data can be arranged in order, but the differences between them are not meaningful. An example of this is the Olympic gold, silver, and bronze categories. So, clearly one would not have silver before gold, therefore there is definitely an arranged order that they need to go in. But the differences between the levels may not be meaningful. This means that the difference between time of, for example, a runner who earned a bronze medal and one that earned a silver medal could be very different than the difference in times between the person winning the silver and the gold. That means if I know the difference in speed between the person who won the silver and the bronze medal, that does not give me any chance of accuracy of them predicting the difference in speed between the person who won the gold and the silver. Interval data has differences that are meaningful, but there is no natural zero, and the ratios are meaningless. And a good example of this is body temperature. So, if you have a body temperature of 98.6 degrees Fahrenheit, that means your body is at a normal temperature and you are healthy. However, if you have a body temperature of 100.4 degrees Fahrenheit, you now have a fever and you are unhealthy and probably need to be going to the doctor. Now, the difference between these two is 1.8 degrees of Fahrenheit. When we look at the third example of 87.4 degrees of Fahrenheit moving to 89.2 degrees Fahrenheit, this is also a difference of 1.8 degrees Fahrenheit. However, here, the difference between the two is not very meaningful, as regardless, both temperatures have you at a state of hypothermia. Thus, they're both unhealthy. lastly is ratios. Now these have a natural zero and the ratios are meaningful. Examples of this mean time, heights, and distances. So if we drove one distance, say that was 120 miles, and then we drove another distance that was 60 miles, it would be meaningful to say that the distance for this first trip of 120 miles was twice the amount of the distance for the second trip of 60 miles. Let's look at another example and pay attention to how actually data from one level can be converted to another. For example, in this course, you have a number of points earned in the course. All right, there's a natural zero in the sense that you can literally earn 0 points. That would actually almost take effort, but you can do it. All right, and the ratios between each of them are meaningful in terms of how many points you have. However, when I convert your points in the course to your letter grade, they move on to a particular grade scale. If you look at the grade scale and the policies, you'll see that the differences between letter grades is not always exactly the same. In fact, I've leaned the grading scale just a little bit to make you more likely to get a higher score. Take a few minutes and take a look at the grade scale for the class, and notice that in comparison with looking at the number of points you could earn in the course to help you clarify this example. This will conclude this lecture looking at numbers and particular types of data. The next lectures we'll have will be moving on and looking at collecting sample data